So far we have seen various types of polynomials, namely constant polynomial, linear polynomial, and quadratic polynomial, cubic polynomial, and polynomial in general. Px is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc a1x plus a naught, which you have seen, and also the standard form of the polynomial, which you have seen. And now by factorization method, how we have found the zeros of the polynomial in the previous videos. Now we are going to consider geometric meaning of zeros of the polynomial, or finding the zeros of the polynomials through the graphs. Now we can see geometric meaning of the zeros of the polynomial, or finding the zeros of the polynomial through graphs. Now, what is coordinate geometry or analytic geometry? Through this type of geometry, we can visualize the polynomial as a graph. Now, in a coordinate geometry is an algebraic realization of a Euclidean geometry. Its introduction to the field of mathematics is by René Descartes, a French mathematician, philosopher, and a scientist who lived during the period 1596 to 1650. How he did it, we can see here. As you know, any real number can be represented on straight line. You can see here. Now we can write the straight line here. We can just mark any point on this straight line as 0, any point, whatever, wherever you like, you do that. And now represent 1 on this straight line, 2 on this straight line, and 3, 4, so on, so forth. Minus 1 to the left of 0, minus whole numbers are represented. As you know, a real number is 1, which can be expressed or identified as a point in the real line or a straight line. And now you can see 3 by 2 here, 3 by 2, and 7 by 2, that is between 3 and 4, sorry, 7 by 2, so on and so forth. Then what about an ordered pair? Pair like 3 and 5. How we can represent it? Now we can consider, let us consider two mutually perpendicular lines, like the right side of the figure here, where x dash ox x dash x and y o dash o y dash are the two mutually perpendicular straight lines intersect at what can say intersect at here. O is called origin, and x dash ox as x-axis, and y dash as y-axis. So in this axis, we can represent the ordered pair. How do you do it? Now we can see. Now consider the ordered pair mentioned about 3 and 5. Now we can see 3 and 5, which I can write down here 3 on x-axis. 3 is a positive integer, so we can look at to the right side of 0 and draw a line parallel to y-axis, and from this y-axis a line parallel to x-axis. A point of intersection here is 3 and 5. This is 3 and 5. Similarly, we can see here, similarly, minus 2 and 3. Here to the identify the minus 2 here, and similar way we can write down parallel line parallel to y-axis, and 3 parallel line parallel to x-axis. So this is a point minus 3, minus 2 and 3, and another point we can say minus 3 and minus 5. We can see here the point minus 3 parallel to y-axis, and minus 5 parallel to x-axis. This is the point where you can see here point. This is minus 3 and minus 5. It is just exactly symmetric point, symmetric to 3 and 5. And also we can see another example of the point which you can represent here, 5 and 2, minus 2, which you can say 5, a line parallel to y-axis, and from minus 2 parallel to x-axis, and this is what you can say, this is the point 5 and minus 2. Now here you can see the point where is the first quadrant. We can write down this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is fourth quadrant. So whole plane has been divided into 4 parts. One first part, first quadrant, only positive first quadrant, where both ordered pairs are positive. And in the second quadrant, where ordered pairs, the first number is a positive, negative, and the second number is positive. Similarly, we can say in the third quadrant, both the numbers, ordered pairs in both the numbers are negative. And in the fourth one, the first one is positive, the second one is negative, and so on and so forth. Like this, we can represent the points in the plane. Here, an ordered pair AB, where A is called x coordinate and B is called y coordinate. It's respectively. So in this fashion, any point can be represented in the plane either in the first quadrant or in the second quadrant or in the third quadrant or fourth quadrant respectively.